Hello, I'm Vishal Misra. I'm the RKS Family Professor of Computer Science at Columbia Engineering. I teach courses that sit at the intersection of computing, systems, and applied problem solving. I also work closely with colleagues across engineering and the university on how we teach foundational reasoning skills.
I'm Chen, lecturer in chemical engineering and director of master's studies. Material energy balances, also known as MEB, is the first technical course our undergraduate students take, and it's often their first time that they have to think like chemical engineers.
Like many instructors, we were facing a familiar problem made sharper by AI. Students could increasingly generate answers very easily, but that didn't mean they were developing judgment. In early core engineering courses like material and energy balances, one of the hardest skills to teach is critical evaluation, recognizing flawed reasoning, questioning assumptions, and explaining why something is wrong.
Students need to look at the AI output and think critically to determine whether or not they believe the response. To make it even more difficult for students to decide whether to trust the output, AI chatbots often sound very convincing. In the real world, students will need to be able to determine if what they are reading or hearing is reliable, be it human or AI generated.
So instead of asking how do we stop students from using AI, we asked a more old-fashioned question. How do we teach students to think like better engineers? Working with my colleague Chen in chemical engineering, we developed what we call a Novice chatbot. Unlike most educational AI tools, this chatbot is intentionally imperfect. It's designed to behave like a confident but error-prone student, making exactly the kinds of mistakes real students tend to make.
We required students to use the chatbot on particular homework problems, where they need to copy a particular prompt into the MEB Novice chatbot and 1. Evaluate the correctness of the response, 2. Explain why they believe the response is correct or incorrect, and 3. Rate their general confidence in the output of AI chatbots.
In other words, the AI doesn't replace thinking, it provokes it. The student's job now is to critique, not to copy.
Outside of these assignments, students were free to use the Novice chatbot however they'd like throughout the course. Students asked the chatbot questions about the course concepts, used it to practice problems, and studied with it in various other ways.
At first, students were surprised. They're used to AI acting like an expert. But once they realized the bot could be wrong, and wrong in realistic ways, they leaned in.
One student told me she used the chatbot as a study partner for the final. She'd solve a problem, compare a solution with the chatbot's solution, catch errors in the chatbot's solution, and fix the errors, which made her feel more confident in her own problem-solving abilities.
Many students told us it felt like practicing against a sparring partner rather than reading a solution manual. And importantly, it made them more skeptical not just of the chatbot, but of any answer that sounded polished. We saw several encouraging outcomes. Students spent more time explaining why an answer was wrong, not just fixing it. Classroom discussions also improved because students had a shared artifact to debate. And students became more reflective about AI itself, recognizing that fluency includes knowing when not to trust it. This was less about efficiency and more about depth, which is exactly where early engineering education should live. The biggest learning for me was that AI works best in the classroom when it's constrained by pedagogy. If you design the tool around a learning objective, in this case critical thinking, it can reinforce the values we have always cared about rather than undermine them. Ironically, by building an AI that makes mistakes, we ended up teaching students to be better thinkers.
Reviewing the chat logs of the chatbot allowed me as an instructor to see how students were using it and help me identify what to emphasize in the classroom, and where I could better guide students in using AI to support their own learning. My advice to colleagues interested in doing something similar is to think about how you want students to think about AI and not just how to think with AI. Thinking with AI could be using the chatbot to help you write, research, or code, whereas thinking about AI is to consider the limitations and appropriateness of AI in a particular context.
My advice to other faculty is simple: don't start with the tool. Start with the skill you want students to learn. This idea adapts well beyond engineering. Any discipline where students evaluate arguments, proofs, interpretations, or designs could use a similar approach. The AI doesn't need to be brilliant. It just needs to be plausible enough so students are challenged to respond thoughtfully. After all, good teaching has always been about asking students to engage with imperfect ideas. And we have just found a new way to generate them on demand.